Hey guys, and welcome back to another video. Today we're starting a new algebra topic called systems of equations. Now we're going to use the systems of equations to solve a classic Math Olympiad problem. Now if you have participated in the Math Olympiad competition, you would know that the problems are pretty tricky. However, there is a perfectly effective way of solving every single one of them. For example, let's say we have this word problem right here. We're at a movie theater, and there is a certain cost to watch the movie. The cost for each child is $5, and the cost for each adult is $7. Now there's a group of 10 people that come, and they consist of both adults and children. They pay $62 to see the movie. How many adults and how many children are in that group? One way to solve this is to guess and check, but that would take a long time. And besides, this is only 10 people. Imagine if there were 100 people. That would take forever. Instead, we can use the simple systems of equations to solve it. Like many other Math Olympiad problems, it's best to use variables. Let's say that the number of children is x and the number of adults is y. The first equation that we can create is x plus y equals 10. This means that the number of children plus the number of adults is 10 total people. Next, we need an equation for the cost. Since the cost per child is $5 and the cost per adult is $7, the cost of the total group is 5x plus 7y equals 62, which means $5 per child plus $7 per adult is $62 total. Here's one thing you can do. You can rearrange the first equations by using inverse operations. Let's say we rearrange the equation into x equals 10 minus y. In the second equation, we can use the first equation to substitute the x for 10 minus y. So instead of 5x, it will be 5 times 10 minus y plus 7y. Using the distributive property, we can simplify that to 50 minus 5y plus 7y equals 62, which can also be simplified to 50 plus 2y equals 62. Using the inverse operations, we can conclude that 2y equals 12 and that y is 6. If y is 6, then 10 minus 6 is x, so x is 4. So in total, there are 4 children and 6 adults. This method of solving is called the substitution method, but this isn't the only method we can use to solve this. The second method is called the elimination method. Here's how it works. Let's go back to our previous equations. If a variable in the first equation has a common factor with the variable in the second equation, you can multiply the first equation by a value so that the variable is the same as the second equation. For example, let's take x of both equations. In the first equation, x has an invisible coefficient of 1, because 1 times x is x. In the second equation, x has a coefficient of 5. We can multiply the first equation's x by 5, so that the two equations' x has the same value. But instead of multiplying only x, you have to multiply the entire equation. So the first equation will become 5x plus 5y equals 50. When you subtract the two equations, both of the 5x's will cancel each other out, and we'll be left with 7y minus 5y equals 62 minus 50. We can simplify this to get 2y equals 12 and y equals 6. As you can see, we got the same answer as the previous method. You can use whichever method works for you to solve these types of problems. But remember, it depends on the equations to decide which method is easier. But other than that, that's it for today. Thank you for watching. Hopefully you learned something new, and I'll see you in the next video.